Number 12, v of t is equal to sine t. In this case, I've drawn out sine t, and I want to find out the displacement from 0 to pi over 2. That would then represent that area underneath that curve. Again, we have the same problem as example 11, where the area cannot be easily calculated because of that shape. We can again estimate using rectangles, but to get that exact area is difficult. But what we can do is we can use that connection between the derivative, the area under the derivative, and the displacement on the antiderivative. So the antiderivative function d of t, the function that gives me sine t when I differentiate, is going to be negative cosine of t. And again, there is going to be this plus c, but what we want then is the displacement or the change in the antiderivative function, or change in the d function. And when we use the change, that plus c is going to cancel out. So the change in the d is going to be d at pi over 2 minus d at 0. They each involve a plus c here and a plus c here, which cancels out, so we're not going to worry about that plus c. And the displacement, the change in the distance function, is going to be the position at pi over 2, or cosine, negative cosine of pi over 2. Okay, that's going to be 0 minus the cosine, or negative, minus the negative, or plus cosine of 0, which is going to be plus 1. So then the displacement is going to be 1, or 1 meter. And that means then that the area underneath this curve is going to be about 1 meter. And if we take a look at the units here, this is approximately 1.57. That's a height of 1. And we're looking at maybe 2/3 of that area inside this red box here. And that then looks about right. That's going to be, that red box is an area of 1.57. And that area that I'm going to fill in is approximately 2/3 of that area, or 1 meter.